JANZZ.technology, the podcast.
Welcome back, everyone. Today we uncover the realities of artificial intelligence, hiring, and the future of work. I'm your host, Laura Flamaric, and today we are tackling a crucial question. Can large language models really replace human recruiters? The answer is no. But why? To help us break this down, we have a special guest, Alejandro Jesus Castañeira Rodriguez, our principal data scientist. Welcome.
Thank you, Laura. I'm excited to be here.
So let's start. We hear a lot about large language models, LLMs, like ChatGPT, being used in recruitment. They are scanning resumes, writing job descriptions, even conducting preliminary interviews. But why can't they fully replace human recruiters?
Well, large language models are incredibly powerful when it comes to processing text, but they lack true understanding. They don't comprehend context the way human does, and they certainly don't have the intuition or judgment needed to make complex hiring decisions.
Why do you think so many people think they can understand?
Well, it's probably because they are very good at generating convincing responses, but in reality, they are not reasoning, feeling, or making any type of analysis the ways that humans typically do.
But sometimes, and sorry to insist, they seem like they can reason. How does this happen?
Well, they are called large language models because these, by definition, are systems that can predict the next element in a sequence based on a list with all the previous elements. This could be either a single word at a time, or you can predict complete sentences. Modern chatbots or LLMs-based apps are just translation systems. These are models that were trained to generate answers based on a question. The original architecture of these LLMs called transformers. The transformers were introduced in a paper as basically and purely a translation tool. So it was used to translate English to German, German to Spanish, Chinese to Vietnamese, and so forth. But then some folks have the idea to use these models to translate questions and answers. And what they did is they gather a lot of questions and answers, and they call it GPT-2. Each new iteration of this new model is just a huge compendium of more answers to more questions. And they keep calling like that GPT-4, 5, 6, whatever. It's like you can do the same with a parrot. You take a parrot home and then...
A bird, like a parrot.
Like a parrot, like
Yeah.
a bird, exactly.
Okay.
And then you just teach in the parrot, like this bird, I tell you this, you say this. You tell this, and I say this. You tell this, and at some point, you are hoping, because most of these systems, what they are doing is they are hoping that the more tricks they teach to the parrot, it will become intelligent as a human. And I am really doubtful that this will work.
Right. Could we see an example in HR?
Okay, in HR, let's say you give a selection of resumes to an AI that they are applying for a given position, let's say in IT, in a software development company. And then you say this language model, okay, can you please select the most promising resumes for an interview? Which is, by the way that most of the companies are doing like that, this so-called generative AI recruiting companies. It's basically a big ChatGPT wrapper.
And what does that mean?
So basically, they do a business model, and in the back end, they have a pay subscription to ChatGPT, and they ask ChatGPT for the question from their customers. Basically, they have a list of resumes from customers. Hey, can you rank these resumes? And instead of the customer doing themselves on their website, they do a prompt to ChatGPT. Hey, ChatGPT, my friend, I have a use case for you. And then they give this result backs and charge customer for the specialized in domain solution.
Okay. Good example. So That's a major concern with AI in hiring, indeed. Even if the model isn't explicitly programmed to discriminate, it can still learn bias from past hiring patterns. If a company historically favored certain demographics, the AI might reinforce those trends rather than correcting them, right?
That's a very good point. The main issue with this model is the training data. Most of this training data is based on historical data, right? Past records of previous hires. And unfortunately, in IT, there is a big bias, right? In software engineer has been mostly a male dominant profession. So you can expect the type of outcome that you will get from the training of models using this type of information. Most of this bias will be replicated and even amplified, sorry. Then this can happen with many things. It can happen also with race, ethnicity, birthplace. This model learns from all the information in a resume and in the hire. So it's not clear how to specify which pattern the model should learn from. Then bias can arise like in many different type of patterns.
Okay. So, we agreed then that AI could end up reinforcing biases rather than eliminating them. And that's really concerning.
Yeah, we are looking from the way of a company ranking resumes, right? But also happens to job seekers. For example, when you upload your resume or you are doing a job search, right? You want to get the most relevant matches to your resume. And the problem with LLMs is like they are basically purely based on text. So sometimes they even use computer vision, but there are no really knowledge representation. There is no word understanding. So it's more like a black and white matching. If you don't use the right keywords that the employee is describing in the job description, probably you will not get a match. For example, the taxi driver occupation. This occupation in many countries, let's say Latin American countries when I come from, has very, very different terminologies. You can say these guys are a botero, machacante, even tuk-tuk driver, just to name a few. So basically an element, if it wasn't trained explicitly to understand that taxi driver is equal to this type of occupations, so most likely you will miss all these opportunities, hundreds of potential jobs. And this is just for one location or one occupation. You can imagine it happens also with different skills, different education. If your keywords are not understandable by the language model, you will get no results.
Okay, that's very good to know. So what about the interview process? Let's say that the LLMs select a good set of candidates and LLMs will do the interview. What is the downside?
Well, hiring truly requires empathy, judgment, and definitely a human touch. Recruiters typically listen not just only for the words, but how the candidate explain their thought process, their adaptability, and creativity. A recruiter will mostly dig deeper and ask something like, tell me about the time you solved this technical challenge when we are speaking about, let's say, an engineering position. And then also, besides listening to your answers, they will be able to read your body language, right? Your enthusiasm, your attitude, and so on and so on.
Yeah, so they can't really evaluate a candidate's true potential, can they?
No. An AI is just basically based on a very limited set of features, like maybe text, and in some cases even some visual input. But that's it. They work really well as a system, and they are very good text generator to generate text and convincing text, rephrasing text is good. They are really great, but hiring is way more than that.
Okay. I had searched an example. Maybe definitely you know it. Maybe our listeners as well. It's about the Amazon AI recruitment tool that they designed back in 2018. Amazon developed this system to rate candidates by analyzing patterns from resumes of successful hires in the past, so hires that Amazon had. And the idea was to automate the hiring process by using data to predict future success. However, the system ended up amplifying biases that were already embedded in the historical data, which led to some serious problematic outcomes.
Absolutely. This system taught itself that male candidates were preferable and it started penalizing resumes that include the word woman. Typical examples just like woman chess club, captain, woman as a gender. And there was a clear case of bias. Unfortunately, large language model only learn from the training data, which often carries this type of prejudice.
Can the bias be fixed?
Well, yes and no at the same time, or it's extremely difficult.
So you cannot do a patch there and go on.
No, for large language models, what you do is that you have to retrain this model again. The only way to teach this model something is to collect new data. Hopefully, this new data will be unbiased, and then you retrain this model once again, which, by the way, is extremely slow, extremely expensive, and is really damaging for the environment.
So if we try to correct one bias, we could accidentally create another one, right? So for example, balancing gender representation might unintentionally disadvantage other groups. How can we make sure that fairness techniques don't lead to new forms of discrimination?
Well, that's a good point. And I think it's very important to understand that fairness as a concept is a really complex, multidimensional issue. When we're trying to fix one bias, we need to be cautious not to reinforce or introduce a new one.
Yeah.
For example, bias mitigation in one type of demography may negatively affect another type of demography. So it's a balancing act, and this process of ongoing evaluation is a key factor. That's where continuous monitoring and feedback loops in development plays a big role.
In what way?
Well, first off, you need diverse and representative data. And to be really honest, getting this right is right now the trickiest part. And there is also another issue in this scope that maybe we don't talk about this. A lot of training data that's been collected to train these models is used in ways that violate privacy rights and intellectual property. Many AI models were trained on massive amount of data scraped from the internet without the proper consent of their authors. Platforms like LinkedIn, personal blogs, online forums, social media profiles, this can raise serious ethical concerns.
This is a serious concern. It's happening without consent and becoming normalized. Many creators likely never agreed to have their content used this way. Companies that use AI trained on unethical obtained data are, knowingly or not, contributing to privacy violations and intellectual property theft. Is there a way to prevent this? If so, how?
Yes. To prevent this, we require both ethical guidelines and real-world solutions. For example, at our company, JANZZ.technology, transparency is key. We strictly comply with data protection laws, and we will never use or have never used illegally scraped data or anything that violates any privacy rights. Our mission here is to build AI-driven HR tech that promotes fair and equal employment opportunities through ethical and completely unbiased technology. We follow the 7 principles of AI ethics in HR tech to ensure that our solutions are safe, they are responsible, and they are fully compliant with legal and regulatory standards.
What about transparency, the black box issue? The lack of explainability in some AI systems can lead to mistrust. How do we handle these challenges of making decisions understandable, both internally and to candidates?
Transparency is a major concern, Laura, because AI models are often seen as a black box, where even developers, even the same creators, sometimes they don't even know how exactly the decisions are made. The main thing is that LLMs and even traditional machine learning models are based on probabilities. They consist of many layers of artificial neural network where they make their prediction based on the mathematical activation of their nodes. So there is a lot of maths operation involved there. This big computation is almost or completely impossible for a human to follow, and then doesn't necessarily translate directly into real world processes. Nevertheless, in recent years, some effort has been made to explain this. For example, in natural language processing, there are some methods that allow you to see which part of the text the network is taking into consideration, or as we call in the field, paying attention to make a given decision. But at the end of the day, this is still not enough to solve the explainability issue.
So, what alternatives do we have? Do we incorporate language models or classical machine learning models into recruiting procedures without creating bias and in a way they are explainable?
Excellent question. First, we will need to define a crucial point. In what stage of human resource procedures should AI be involved? Definitely not in the interviewing. And I could also go even further to say that in the screening part, neither. A matching engine which is purely based in machine learning will not work, at least not with the current technology available. I think that the safest component to use traditional machine learning models, not even LLMs, is in the information extraction step. For example, to create good quality data from unstructured resumes and job descriptions. This data can later be used in matching engines, not in a free form of text or file, but as a well-defined set of features, which in our domain, in the human resource domain, will be occupation, skills, experience, and so on. Luckily, at JANZZ, we have developed and trained specific HR models in this scope for the task of structuring information. Each of these models has a very specific role and is training on data that is gender agnostic, not in the full text of a job or a resume.
What do you mean with gender agnostic data?
So basically, we extract only hard competences from HR data. No personal information is involved. Also, these records are structured into concepts. Let's say, for example, take the occupation software developer. In Spanish or in our language, you can have two variations depending on the feminine or masculine of this occupation. Then you can identify gender, and you can have even different matches depending on the language model that you use with one gender or the other. In our case, what we do is we encapsulate all these different genders of software developer in different language into one single entity, one single concept, software developer. That's it. Then it doesn't matter which gender you are using for matching, they all belong into the same semantic entity. Also, in our approach, all the personal information is disregarded. Name, birthplace, picture, nothing of this is considered for matching.
Interesting idea, Alejandro. So it is like moving away from the text or abstract neuronal networks into real life concepts. But then, how do we know how to track these concepts, their meaning, relationships, multilingualism, etc.?
Well, that's a very good question. So in this case, we will need to store all this information in a system that is designed for this purpose, which will be what is called a knowledge graph. Knowledge graph store and relate information from real-world objects, giving them a clear definition and interpretability. In our company, as we discussed before in a previous podcast, we have developed our own knowledge graph in the human resource domain. It contains thousands of concepts organized in education, skills, occupation, and so forth. These concepts are constantly maintained and updated in multiple languages to ensure that they are consistent with the current job market.
Then, what are the benefits of using this approach based on knowledge graphs concepts versus traditional machine learning models?
So, First of all is the accuracy. If we go back to the taxi driver example, we will know in our knowledge graph all these different variations of taxi driver are included inside a single concept into our knowledge representation.
Mhm.
So when you search for a taxi driver in Latin America, let's say in Cuba, where I come from, you will have suggestions for very peculiar terms as machacante, botero, tirapasaje, etc. This allows for really comprehensive matching. The second dimension is the removal of biases. As we don't use personal information and all concept sits into a single entity with all genders, terms such as, let's say in Spanish, profesor, which is a teacher, has a feminine and masculine profesor, profesora, nurse, or doctor can be a doctor, doctora, will all match between each other. Doesn't matter of the gender, and doesn't matter if it is in a job or a CV. And this type of gender inflection will never affect search results. And the third dimension, which is actually absolutely important, is the matching explainability. With our pure knowledge graph approach, it is really clear to see why a match between a job description and a CV has been produced. As we are comparing well-defined and concise semantic entities, for example, when we compare seniors to juniors position, educational degrees, skill, etc., knowledge graph, their main purpose is to encapsulate this type of information. And you can definitely see the result of this analysis inside the structure of knowledge graph, which is something that in an LLM you will never be able to do. You cannot backtrack why or look why they give you a precise answer. You can only see the keywords that they use.
This approach sounds very promising. So, are you saying we can trust it completely without human intervention, or will it still require supervision?
Good question. The main purpose of our approach is to make human interactions easier by making the screening of candidates faster. The interview selection process, interview itself, and hire will be still made by a human. We just facilitate having an initial set of candidates by discarding the ones that have no common background with the job offering. Same for jobs. We only give the most likely jobs options for a given job searcher. It's up to this one which one to pursue.
So, we are essentially relying on human intervention to ensure all the crucial decisions. And then the AI will just try to make these decisions easier by doing all the boilerplate jobs that will usually take a long time for a human to do. So, AI is never going to completely replace human recruiters. But how can humans and AI work together? What does the future of recruitment look like in this hybrid world?
Great question. Well, across the industry, we are seeing the trends moving towards a collaborative model. However, the real impact will become clearer over the next 2 to 3 years as we observe how the AI shapes the job market, the economy, and the overall dynamics of the workforce.
While AI can undoubtedly help us streamline tasks, shifting through resumes at a light speed, it's no substitute for the human touch. There's still a lot of intuition, empathy, and judgment that only we, humans, can bring to the table when it comes to hiring.
Exactly. At JANZZ.technology, we recognize the importance of combining both AI and human expertise. AI helps us to be faster and more efficient, automating time-consuming tasks like resume screening and candidate shortlisting. However, we have to make sure to sustain human supervision and every step to ensure accuracy, fairness, and the human-centered qualities that drive good recruitment decisions.
So in the future, it seems that AI and human recruiters will be working side by side. AI will handle the heavy lifting, but humans will still be the ones to make the final decisions, especially when it comes to understanding a candidate's true potential.
Totally.
Thank you, Alejandro, for joining us and sharing your expertise.
A pleasure. Thank you for having me on the podcast.
We hope this episode gave you a better understanding of where AI is headed in the world of hiring and how we can ensure it works in a way that's ethical, fair, and human-centered. Be sure to subscribe to our podcast and tune in next time for more insights on the future of work. Thank you for listening and goodbye.